even said a word yet. That's pretty good. All right, we are doing matrices again today. And what I did, let me make this smaller, is I took the liberty of, see, let me move this over and then maybe make it bigger again. Of taking this system of 3 lines, remember those are, for instance, missile paths in real time, in three-dimensional space, which is where we live. We're not two-dimensional creatures on a whiteboard. We're three-dimensional. Okay, so if you were going to rewrite this the way it actually is, it would be what you see over here. 6x plus negative 1y, that minus y is negative 1y, plus 4z equals 20, and 4x plus 1y plus negative 1z equals 8, and negative 2x plus 1y plus 3z equals negative 3. Okay, I need to do that because I need to fill in my first matrix over here. And actually what I had intended when I made this form, let me, I'm going to have to pull out a little bit so I can see everything together, is to write it like I wrote it over here. It's been a while since I've looked at this form. This is a very helpful form, and I'm going to put this up in modules in your Canvas site so that you can download them and use them as well if you want to. Okay, here we're still working with the system. We're going to turn it into a matrix in just a minute. Okay. Now, just like yesterday, we're going to make a matrix out of the coefficients. So I'll have 6, 4, negative 2, and negative 1, 1, 1, and 4, negative 1, 3, and 20, and 8, and negative 3. Okay, that's the way we start, and this is matrix number 1. Now remember, our goal is going to be, well, we're going to be using a Gaussian elimination. And so when we do that, actually when we use the other method too, we have this goal. The very first goal we have is to take this 4 and turn it into a 0. That little 1 means it's our first 0. Our second 0 is going to be here. And our third 0 is going to be here. And then we back solve. Okay, so I need to be able to add these first 2 numbers, the first number in row 1 and the first number in row 2. I need to be able to add them together so that they will equal 0. That's what I'm going to do over in calculations. Down here in my recipe, I'm going to try to figure out how to go about this. And I think what I'm going to do is multiply all the numbers in row 1 by 2. Let's see, I want to put that in black. Well, I don't have to. 2 times row 1 plus -3 times row 2. And I'll explain that in just a minute. Okay. I know that 6 and 4 both go into 12. So I know that 2 times 6 is 12 and 3 times 4 is 12. And if I were to make that 3 a -3 instead, I would have 12 minus 12, and that would be 0. And that's what I need to have happen. And the rest of the numbers are just along for the ride. So here's what I'm going to do. I'm going to add 2 times all of the numbers in row 1 to -3 times all of the numbers in row 2. And all I care about is what I get when I add these two numbers. Of course, I'm going to add all of them. And then I'm going to use row substitution, where this, what I get when I do that, is going to become, and I'm going to write it down here because I want to leave room here, is going to become my new row 2. Okay, so this is my goal, and it will all make more sense when you see me do it. Especially if you weren't here yesterday, then you didn't see all of this develop. Okay, so I'm going to take 2 times row 1. Okay, so 2 times each number in row 1 is going to be 12, -2, 8, and 40. And then -3 times row 2 is going to be -12, and that's the reason I did it. -3 times 1 is -3. -3 times -1 is +3. And -3 times +8 is -24. And now I'm going to add these two rows together. 12 plus -12 is 0. -2 plus -3 is -5. 8 plus 3 is 11. And 40 minus 24, we'll have 10 minus 4 is 6. And 3 minus 2 is 1. That's going to be 16. So now this is my new row 2. And I'm going to put it in over here. I'm going to let this be matrix 2. So row 2 will be 0, -5, 11, and 16. Meanwhile, row 1 and row 3 stay exactly the same for now. So 6, -1, 4, and 20, and -2, 1, 3, -3. And now my next goal is to turn this -2 into a 0. Okay, well, you can see that if I were to add row 2 and row 3 together, any number I would multiply the 0 by would still be a 0, so I would stand no chance of getting a 0 when I add these two rows together. So I'm going to have to use row 1 and row 3 together. Now I know that 2 goes into 6 3 times. And negative 2 will go into positive 6 negative 3 times. So cool. I can actually get away. I can actually get away with leaving row 1 the way it is, and then adding 3 times row 3. Now 3 times row 3 will give me a negative 6 here, so that when I add 6 plus negative 6, I get a 0. That's what I need. Okay, and this is going to give me the new row 3. Which will go down here. This is going to be my matrix number 3. Let me change to black now. Okay, so row 1 is 6, negative 1, 4, and 20. And 3 times row 3, 3, row 3, is going to be 3 times negative 2 is negative 6. 3 times 1 is 3. 3 times 3 is 9. And 3 times negative 3 is negative 9. And now I add 6 plus negative 6, or 6 minus 6, is 0. Negative 1 plus 3 is positive 2. 4 plus 9 is 13. And 20 minus 9 is 11. And now that's going to be my new row 3. Let me put it in before I forget. 0, 2, 13, and 11. Now, this row 1 and row 2 are going to stay the same. 6, negative 1, 4, 20, 0, negative 5, 11, 16, and then I already changed row 3. Okay. So there we are. This is what we've done so far. Our first goal, well, first what we did is we copied the coefficients into this matrix and then copied these. Then our goal with matrix 1 was to add row 1 and row 2 together and somehow multiply row 1 and row 2 by something so that when we add them together, we get a 0 in this position. And we figured out, well, 2 times all of these numbers will give me a 12 in this position, and negative 3 times all these numbers will give me a negative 12 in this position. So I did that, and this is what I got, and I added them together, and this was my new row 2, which I put in. Let me even put an arrow here. I put that in there. And then row 1 and row 3 remain the same. Now, after doing that, I had matrix 2. Matrix 2 Now my goal in matrix 2 is to add row 1 and row 3 together in such a way that I will get a 0 in this position. So knowing that 2 goes into 3, no it doesn't, 2 goes into 6 3 times, what I did was I left row 1 the way it was, and I multiplied row 3 by 3, so that 3 times -2 would equal -6. And that way, when I add them together, I would get a 0 in that position. And so this would be a 3. I'm just kind of double checking. Yes, okay. Now this, have arrows going all over, this became that. And now, if I add row 1 to either row 2 or row 3, there's no way to, I will lose my 0 in that position, and I want to keep them. So what I'm going to do, because 0 plus 0 is 0, I need to add row 2 and row 3 together in such a way that I will get a 0 in this position right there. And that's the last of these row operations I'm going to have to do, which is pretty good. Okay, so I now need to add, of course I'm going to add 0 plus 0, that's 0. But I need a 0 in this position now, which means I have to add this position and this position together in such a way that I get a 0. And I know that 2 and 5 both go evenly into 10. So that if I multiply all the numbers in row 2 by 2, that will give me 2 times -5, which is -10. And if I add that to 5 times all of the numbers in row 3, then I'll have 5 times 2 is +10, so that I'll have -10 plus +10 equals 0. It's kind of bothersome that these are going to give me bigger numbers, especially with the 5, but I can probably live with it. Maybe. Okay, so let's do this, and this is going to become, maybe I'll write it that way, the new row 3. Again, I'm going to have a new row 3 because I needed to change this position, and then I needed to change this position. So here we go. 2 times row 2 will give me 0, because 2 times 0 is 0. 2 times -5 is -10. 2 times 11 is 22. And 2 times 16 is 32. Now, 5 times row 3. 5 times 0 is 0, and 5 times 2 is 10. And now, 5 times 13. 5 times 3 is 15, carry the 1. 5 times 1 is 5, plus 1 is 6. That'll be 65. I hate big numbers. And 5 times 11 is 55. I get nervous as soon as they start appearing, but they appear a lot. Okay, now we add the two lines together. 0 plus 0 is 0. Negative 10 plus 10 is 0. 22 plus 65 is 87. And oh, 32 plus 55 is 87. Our lives are not going to be so bad, because when I know that that number goes evenly into that number, I can do the following very sneaky approach. I can say, okay, I can divide each number by 87. Now, admittedly, with the zeros, that's just a technicality, because you know that 0 divided by 87 is 0. So I'll still have zeros here. And then 87 divided by 87. Let's see what I get so far. 0, 0, 1. And 87 divided by 87 is 1. You have to do this to every number in the row when you do it. All right, so 0, 0, 1, 1 is going to be my new row 3, and that is not bad at all. So I'm pretty happy about that. Row 3 is now going to be 0, 0, 1, 1. And row 2 and row 3 stay the same. So here I'll put a little arrow going that way. 6, negative 1, 4, and 20. 6, negative 1, 4, 20. And 0, negative 5, 11, and 16. Once I have this triangle of zeros down here, I'm done, almost. But I'm done with the row operations. I'm going to save, because I know what happens. And I am now going to rewrite this matrix right here, which I did not number, bad me. I'm going to rewrite this as the system of lines it really was. 6x, negative 1y, 4z. You can imagine plus signs in between here. And 20. Because this is 6x minus 1y plus 4z equals 20. And then now for row 2, we're going to have negative 5y plus 11z equals 16. Really? Yeah, because it went back to normal. Okay, right, sorry. And now we have this new one, which is 1z equals 1. And duh, check this out. Now we know that z is 1. Now here's what I do. I do something called back solving. This was part of back solving. I should have put a note first before I did that to say we're now in the last part of this problem, which is called back solving. We're going to go backwards. the first thing I do is I start with row 3. Well, it's line 3 now, but whatever. We've got 1z equals 1, which means z equals 1. Now we go backwards to row 2. We'll have negative 5y plus 11 times 1 equals 16. So I'll have negative 5y plus 11 equals 16. I am going to subtract 11 from both sides because now I have to solve for y. Minus 11 minus 11. 11 minus 11 is 0, leaving me with negative 5y. Ooh, and that's going to be 5. I divide both sides by negative 5 because I'm solving for y. Y equals negative 1. Now I know what z is. Z is 1. And y is negative 1. Now all I have to do is find x. To do that, I go to row 1. Let me move this over. Row 1 is 6x minus 1y plus 4z equals 20. And let me make sure that's really, really true. Always doubt yourself a little bit. 6x minus 1y plus 4z equals 20. Okay. Now, 6x minus 1 times negative 1, because y is negative 1, plus 4z, and z is 1, plus 4 times 1 equals 20. So we'd have 6x minus 1 times negative 1 is plus 1, and 4 times 1 is 4, so plus 4 equals 20. And that's going to be 6x plus 5 equals 20. So I'll subtract 5 from both sides. That's 0. So I'll be left with 6x. I am so disappointed. I was hoping it would be nice, even integers, you know? Oh well, I don't mean even, but you know, that number would go evenly into that number, like it did before, kind of hoping, but no chance. I've got 6x, I'm going to, now it's not negative 6, is it? I want it to be right. Okay. Divided by 6, divided by 6. So x is going to equal 15 over 6, but 15 is 3 times 5, and 6 is 3 times 2, so the 3's will cancel, so my answer is 5 over 2, and now I'm remembering that I actually had the chance to see these answers, and yes, that is what x is, So now we put our answer, actually the answer box will be inside braces like this because you're going to get an ordered triple, X, Y, Z. That's the kind of point you get in three-dimensional space because you've got length, width, and height. So X is going to be, no, well, that's too big. Wait a minute. X is going to be 5 over 2. And Y is going to be -1. And Z is going to be +1. And now that's your answer. There is a way to check this. And that's to go back to the original problem. Put the X number in for X, the Y number in for Y, the Z number in for Z, in all three of these and see if you get truthful answers. That is, this side will have to equal 20. This side will have to equal 8. This side will have to equal -3. And I already know the answer's right, but you don't. And so you might want to actually, this afternoon sometime, check the answers. And here, look at this. You've got another sheet down here. Let me save. Now, I realize this seems like a ridiculously long method just to find X, Y, and Z, but I think you'll find that this is the method that will give you the least number of wrong answers. If you go slowly and carefully through this, following the steps that were created by Gauss. I forget what his first name was, but that's why it's called Gaussian elimination. There is a method called Gauss-Jordan elimination. Actually, it's Gauss-Jordan. Gauss was German and Jordan was French. And what Jordan did, Jordan, he took Gauss's method and he said, why should we have to do any back solving at all? And so what he did is he continued the row operations, so that after you would have had this lower triangle of zeros, you would continue getting zeros. This would be your first zero, this would be your second zero, that would be your third zero. So you would end up with, if we had been doing Gauss-Jordan elimination, what we would have ended up with is this. Here. Okay, 1, 0, 0, 5 over 2. 0, -1, no. 0, 1, excuse me. 0, 1, 0, -1, and 0, 0, 1, 1. That would have been how Jordan worked it, which means he keeps doing the row operations. These things are called row operations. He would have continued that until he got this upper triangle of zeros and ones down the diagonal. When that happens, your answers automatically appear. But for people just starting out with this, that can be just asking way too much, whereas it actually does make sense when you're back solving. You know, it's kind of like, well, that makes perfect sense to back solve. Once you find out what z is, it's easy to find out what y is, and then once you know what y and z are, it's easy to find out what all three of the letters are, x, y, and z, all three of the variables. So in college algebra, that's what I teach, and as you go up, especially as you go up into finite, you'll learn Gauss-Jordan elimination, and then some fancier methods too. Business majors, get ready. You're going to be doing this next semester as well. So, do you want to talk about what we did here? Same thing we did yesterday, for those of you who were here yesterday or who watched the video from yesterday. Same exact thing. Kind of over and over and over, the same exact thing. It's very boring, so it's easy to make arithmetic errors if you're not concentrating. I don't like to concentrate that much, and I hate adding, subtracting, and multiplying and dividing numbers. That's why I like algebra better. I make fewer mistakes when I'm doing stuff with X, Y, and Z than if I'm doing it with numbers. I hate numbers, but that's me. You might actually like this better. Is anybody still alive?
I'm here.
Okay, well, good.
Me too.
Good. One person is here. Now we're going to do one of the last problems in your homework, and that's a word problem. How do you actually use this stuff? Okay, so let me solve again, and while I'm at it, I'm going to do something called flattening annotations. What that does is it makes the writing permanent, so it becomes part of the PDF. And then I am going to pull up this, because we have to set up our matrix. We have to actually calculate what the numbers are going to be. Okay, and yeah, having moved beyond X, Y, and Z. Now this has nothing to do with movement in three-dimensional space, which is my favorite example. Yeah, I'm not going to go over it again. Okay, this has to do with money, and that's pretty important too. Matrices often is applied to numbers, so let's read this. You've got Gonzalez Manufacturing, and they borrowed $33,000. Part of the money was borrowed at 4%, part of the money was borrowed at 6%, and part was borrowed at 8%. The annual interest was $2,040. That is the amount of interest that was paid on each part. Okay. And the total amount borrowed at 4% and 6% was twice the amount borrowed at 8%. Use Gaussian elimination to find the amount borrowed at each rate. You have really got to go step by step on this. I have to also. So first we have to read it again and then read it again and kind of put the parts together. There are three different amounts that are borrowed at three different interest rates. So if I write down what that is, okay, for instance, that at 4%, and at 6% and at 8%. Those are the three amounts. Okay, and so if I let X be the number of dollars borrowed at 4% interest, and Y be the number of dollars at 6% interest, and Z be the number of dollars at 8% interest, what it says up here is that the total amount borrowed was $33,000. So X dollars plus Y dollars plus Z dollars has to be $33,000. And the total annual interest that was paid for this money, because when you borrow money, you have to pay interest, you make payments on it. That was $2040. Okay, well, that means that the amount of interest I had to pay, or Gonzalez Manufacturing had to pay on the X dollars, was $4%. And the amount of money they paid on the Y dollars was 6% of the Y dollars. And the amount of interest they paid on the Z dollars was 8% of the Z dollars. And so the total amount of interest they paid was $2,040. $2,040. Okay. Now that's just part of it. And I'm having to really think when I'm doing it. So I'll get another glass, another cup, another drink of water. Because now we're being told different stuff. Okay? The total amount borrowed at 4% and 6%, that's X and Y. Was twice the amount borrowed. Let's see, the total amount borrowed at 4% and at 6%. Now I'm taking that to mean that each of these is going to be twice the amount borrowed at 8%. So I hope I'm understanding them correctly. Language can be bothersome. How about that? So for X to be twice the amount of Z, this is what I would write. And for Y to be twice the amount of Z, I would write that. Does that look right? Or should it be X plus Y is 2Z? The total amount borrowed at 4% and 6%. It doesn't say the total amounts borrowed at 4% and 6% were twice the amount. It says the total amount borrowed at 4 and 6% was twice the amount borrowed at 8%. At this point, if you were at home, I would recommend that you go to show me how to solve this. No, because that'll make you get another problem. Go to show me an example and see how they do this part of it. Are they saying that X plus Y equals 2Z? Or are they saying that X is 2Z and Y is 2Z? I don't know. I'm going to take a chance. How about that? So if x equals 2z, we would have x equals 2z, but we would have to pull this over here. So that x minus 2z would equal 0. And then y minus 2z would equal 0. We're not supposed to have 4 lines, so I am going to make a guess that could be right or wrong, that what they're saying is that x plus y equals 2z, and I'm going to go with that, and we'll see what we get. Okay, so here we go.
Miss Barbara,
Yes.
why did you put 2z minus equals 0? What you
Your microphone is going in and out.
Oh, so question was, why did you 2z minus 2z? So what you
Oh, because you're going to see this in just a minute. I'm going to do it again. Okay? I am going to guess that what they're saying is that x plus y equals 2z. Okay. The way I have it written right now is the z should be over here and not over here. So the reason that I was subtracting and that I'm going to subtract now is that okay, is that I'm not allowed to have any of the variables over here. So I had to move it over here. And once I did that, I would have a 0 over here. And 0 is a number, and I'm allowed to have a 0, but I'm not allowed to have an x or a y or a z term over there. This is where the pure numbers go. Now there's something else I can do to make life easier as well. I could multiply every number by 100 in order to get rid of the decimals. And I think I'm going to do that. So I'm going to put parentheses around this and say multiply by 100. So that now this is what I will have when I go to actually make a matrix. Like I said, I do hate big numbers.
Miss Barbara, why were we multiplying by 100?
Because that will move the decimal point over 2 places. And we won't have decimals anymore.
Yay!
We'll have numbers. Yeah, whole numbers. I agree. Yay! Okay, so here's what we're going to have that I'm going to put on the sheet. X plus y plus z equals 33,000. Although I think I'm going to have to move that over. Move it over a little bit. Okay, now, if I multiply this term by 100, I'll get 4x. And if I multiply this term by 100, I'll get 6x, 6y, 6y. And if I multiply 100 by this term, I will get 8z. And that's going to equal, are you ready? We're going to have 2040 with 2 more zeros put on. So this is going to be 204,000. And you'll see if you multiply 2040 by 100, it becomes 204,000. Multiplying by 100 just puts 2 more zeros on there. Meanwhile, I'll have x plus y minus 2z equals 0. And there we go. So let me solve. And now we are going to go. I'm going to move this over. And then I'm going to, no, what do I need to do? I need this. Ha, messed it up. Okay. Here we go. And now, oh, I should have gone here. To here. And that takes over, doggone it. Okay, I know what to do. No problem at all. I am going to do this. Microsoft is so creative. My snipping tool is my favorite tool. There we go. Because now all I have to do is call up the snip. X plus Y plus Z equals 3,300. And now it's going to disappear for a minute, but that's okay. Thousand, 33,000. Okay, and 4x plus 6y plus 8z equals that humongously big number. No. $204,000. And then we've got x plus y minus 2z equals 0. Now what they want us to do is use Gaussian elimination, but I can already see a quicker way of doing this. so that you could instantaneously find out what z is, and that is that x plus y equals 2z. We found that out already. This would be 2z plus z, that would be 3z. That would make z 11,000. But we should be legal, I guess, about this. Really, we should. So we're going to do it. Okay, this is 1x plus 1y plus 1z. Okay, so that's going to be in matrix 1, that'll be 1, 1, 1, 33,000. And 4, 6, 8. 2, 0, 4, 0, 0, 0. And then, okay. And then 1, 1, negative 2, 0. Okay, before we start, notice that everything here is an even number. I could, it's always debatable, I could divide everything by 2 to make the numbers a little bit smaller. The thing is, would it do any good? I think it might, but let's just leave it the way it is and work on it. We don't have all the time in the world. My first job is to take this 4 and turn it into a 0 by doing row ops. So I'm going to take 4 times negative 4. Negative 4 times row 1, so that I can get a negative 4 up here and add it to 4. So I'm just going to leave row 2 the way it is, and that will give me my new row 2. Okay, so negative 4 times row 1 is going to be negative 4 row 1 is going to be negative 4, negative 4, negative 4, and I will get my calculator and multiply negative 4 times 33,000. Hello, come on. There. Okay, negative 4 times 33, 0, 0, 0. Enter. Negative 132, 2000. Negative 132,000. Okay, we can do that. All right, meanwhile, row 2 is going to stay just the way it is. 4, 6, 8, 2, 0, 4, 0, 0, 0. Calculator, come back. There it is. You ran away. Naughty. I would too, looking at these numbers. Okay, so here we go. Negative 4 plus 4 is 0. Yay! Negative 4 plus 6 is positive 2. Negative 4 plus 8 is positive 4. And we are going to take negative 132,000 and add it to 204,000 and hit enter. So I get 72,000, which is a lot better than it was. Not only that, but now I know for sure that 2 goes evenly into each of these numbers. So I am going to divide by 2, divide by 2, and divide by 2, and divide by 2. And I think that makes this 36,000, but let's make sure. Okay, 72,000, 72000 divided by 2. Enter. Yeah! So we'll have 0, 1, 2, 36,000. Oh, and that's my new row 2. Nowhere near as bad as it was before. 0, 1, 2, 36,000. Now the other 2 rows stay the same. 1, 1, 1, 33,000. And 1, 1, negative 2, 0. Now I have that. Now my goal is to put a 0 here by adding row 1 and row 3 together, because adding row 2 to row 3, the 0 wouldn't change, so I would not be able to get a 0 in that position. So instead, I'm going to take row 1 and leave it the way it is. But I want to change to black. I want to be consistent as long as I started doing that. I'm going to take row 1, and then I'm going to add negative 1 times row 2. Okay, so that I'll get a negative sign here, so I'll have 1 minus 1, and that'll be 0. Okay, so row 1 is going to be 1, 1, 1, 33,000. And negative 1 times row 2 is going to be, it's row 3. There you go. That's ugly. I'm going to erase it and do it again. Row 3.
And Miss Barbara?
Yes.
Change that 2 into a 3 for the recipe.
Oh, did I write 2? Yes, I did. I thought 3, but I said 2. Isn't that amazing? Wars have started over less. There you go. Thank you. Now, negative 1 times this stuff will give me negative 1, negative 1, positive 2, and still 0, because negative 1 times 0 is 0. And then I'll add them together. Oh my goodness! Okay, 1 minus 1 is 0. 1 minus 1 is 0. 1 plus 2 is 3. And 33,000 plus 0 is 33,000. Now, since 3 goes into 33,000 evenly, I can go ahead and divide every number. So we're going to have 1, and we're going to have 11,000. So this is almost perfectly solved. In fact, we're almost done. They have saved us so many steps. Okay, so let's go back here. Let's just write out the third matrix. Matrix 1, matrix 2, matrix 3. We'll have 1, 1, 1, 33,000. I'm not being consistent. I need to be. I should have copied that first. This would be 0, 0. That was 0, that was 0. 1, 11,000. And we would have 0, 1, 2, 36,000. Okay. So, all right, I know what Z is. Do you see that? That's one Z, because this is Z, this is Z, this is Z, this is Y, this is Y, and this is X. So I'm going to back solve. I know that Z equals 11,000. Now, I'll go up to the second row where I'll have 1Y, or Y, plus 2Z equals 36,000. So Z is 11,000, so that'll be Y plus 2 times 11,000 equals 36,000. And so that'll be Y plus 22,000 equals 36,000. Subtract 22,000 from both sides. That leaves me 14,000. So I'll have Y equals 14,000. Do you see that? I subtracted the 22,000 over. I was left with Y. So Y is all I've got now. So Y is 14,000. Then what I'm going to do is write down row 1, which is X plus Y plus Z equals 33,000. So that's going to be 11,000. And that's going to be 14,000. So that's going to equal 33,000. And so we'll have X plus, now we're going to have 14,000 plus, yeah.
Miss Barbara,
Yeah,
wouldn't X be 11,000?
well, probably, but I just want to make sure.
Oh, okay.
So this is going to be 0, 0, 0 when we add these guys together. 4 plus 1 is 5. And 1 plus 1 is 2. And maybe not. ow, ow. Oh. 33, that's going to be 8. 8,000. At least the way I did it. Now, is it going to be true that x plus y equals 2z? Let's see. 8,000 plus 14,000 equals okay, these guys equal 22,000, and that is 2 times z. So at least for the way I translated the problem, I've got it right. Now, it all depends on exactly what the writers of the problem meant. Let me save this and then switch back to here. It all depends, and that's why word problems drive people crazy. It all depends on what the writers of the problem meant when they said the total amount borrowed at 4% and 6% was twice the amount borrowed at 8%. But I'm more and more sure that this is the total amount borrowed at 4 and 6. I'm pretty sure we did it right, but I'm not 100% sure. So what we both need to do is when we get to this problem in the book, sneak a look at, show me an example, and see how they translated it. Isn't that funny that I've spoken English all my life, and I am not sure which they meant? Does that mean individually 4 and 6 were, that is the 4% amount and the 6% amount were twice the Z amount? Or the 4% amount and the 6% amount together were twice the 8% amount? I can see arguments in both directions. So I want to see what they meant. Are you still there?
I'm still here, Miss Barbara.
Ah, I think it's just you and me now.
Really?
Oh, somebody else is here. Let me see.
I'm still here.
Oh, yay!
I'm still here.
I'm here.
Yeah, we haven't been deserted. We're not all alone. Yay! There we are. Well, a lot of people are here. A lot of people. It never downloads. To heck with them all. Okay, so you can see right away that there would have been a quicker way. We would have gotten 11,000 right away for Z if we had just said, okay, well, if X plus Y are 2Z, then we would have 2Z plus Z, that would be 3Z, equals 33,000. So Z would equal 11,000. 11,000. We wouldn't have to use the matrix at all, but that's what they said to do. And matrices is what you're learning right now and are now totally geniuses at. I think.
I wouldn't say geniuses just yet.
Yeah, well, after the weekend, when you've practiced, you'll be geniuses. Okay, it is now 11:45, which is our official time to terminate. If any of you want to hang around and ask questions, that's great. If not, everybody is free to go. I'm surprised you didn't already go.
Have a great day, Miss Barbara.
I will. And you have a great weekend, but be safe.
Thank you. You too.
Don't go catching COVID, anybody. It's hard to do math when you're coughing.
Miss Barbara.
Ma'am.
So, I would be more than happy to set up an appointment, but I just received devastating news. One of my grandparents from my mom's side passed away
I'm very
last night.
sorry.
It's okay. I was gonna say if I could have a meeting with you Friday. I think I sent you an email. I don't think I hit send quite yet, but I think I'm gonna have to reschedule because his funeral is gonna be Saturday. So
Perfectly understandable.
Yes,
That's
I will keep
perfectly
you up to date.
understandable.
Yes. So I will keep you up to date. I don't think you won't be on campus next week, will you? No.
No.
Uh-oh, rats. Okay. Alrighty.
But we can talk this way. I mean, give it a chance. It's a perfectly good. I have students who come to the office hour, and I know it's not as good as being there in person, but at least we're not going to share diseases that way.
That's true. Gotta be safe than sorry, right?
That's right.
Alrighty, Miss Barbara. Well, I will keep you up to date, okay?
And tell your parents, lo siento.
Thank you, Miss Barbara. Really appreciate that.
Bye-bye.
Bye.
Anybody else have questions? I know it's kind of weird stuff.
It is.
But everything in math in its own way is pretty weird. But you get used to it after you do it for a while. But is there anything I can do to help right now?
Miss Barbara, I know, like, where can I find our material? Because I'm watching our videos, or I'm watching your live streams, but I don't, where can I find, like, maybe, like, our homework and stuff like that? I don't know where any of that's at.
Oh my goodness.
Yeah.
Royce, let me go there.
Okay.
I'll show you.
Please do.
Let's see, am I saved here? No, save. Okay, we're going to bring up MyMathLab. Here's Canvas.
Okay.
Okay, now, do you see where my mouse is?
Yes, ma'am.
Okay, that's MyMathLab. If you click there.
Okay.
Then,
yeah, I get there. Right.
Okay, that's where the homework is.
Okay.
And then students would click here.
All assignments. Okay.
And these are all your homeworks.
Oh.
Like what we just went over.
See, 10.1. Okay, we went over 10.1, right?
That's right.
Okay, perfect. Thank you.
Okay, does that help? I don't want you to not know where the homework is.
Yeah, it does. It does.
Okay, okay, good.
All right, thank you.
You're welcome. Mitchell, anything I can help you with?
No, ma'am. I am golden. I was just finishing up a couple more homework problems.
Okay. All right. Well, if you run into any problems, send me the best way actually is through Ask My Instructor, which is in the question helps. For each homework problem has question helps in the upper right-hand corner. If you click there, you see all sorts of helps.
Okay, perfect.
Including
Thank you so much.
Ask My, I'm sorry, I didn't mean to interrupt. Go ahead.
Oh, no, you were all good. I apologize. I didn't mean to interrupt. I was just saying, I didn't realize that was an option. That is such a cool option. I see that.
Yeah, it is. I want you to get help. I want you to get as much help as you want.
Yes.
And do you know where my office hours link is?
Yes, that should be in Canvas, correct?
Yes, it is.
Perfect.
The first thing you see as you go in, it's going to be down a little bit.
Okay, perfect. Well, thank you so much, Miss Rademacher, and I hope you have a great rest of your weekend.
Me too. And you too. Bye-bye.
Well,